예, 안녕하세요. 저는 바이테캠스의 정진이라고 합니다. 오늘 피닉스 플랫폼 관련 웨비나 시작하도록 하겠습니다. 일단 바쁘신 와중에도 굉장히 많은 분들이 참석해 주셔서 굉장히 감사를 드리고요. 저희 바이테캠스는 서타라사의 국내 디스트리뷰터고요. 윈놀린과 같은 피닉스 플랫폼 외에도 서타라사의 모든 제품을 국내에 서비스하고 있습니다. 오늘은 왜 피닉스가 PK/PD 분석을 위한 업계 최고 검증된 표준 플랫폼인지 확인하세요라는 제목으로 피닉스 플랫폼에 대해서 설명을 드리고자 합니다. 일단 먼저 저희 서타라사의 국내 디스트리뷰터인 저희 바이테캠스에 대해서 간략히 소개를 좀 드리고 시작을 하겠습니다. 저희 바이테캠스는 1991년부터 캠 인포메틱스 및 바이오 인포메틱스 분야에서 전 세계 유수 기업들이 사용하고 있는 최고의 솔루션들을 선정하여 국내에 공급하고 있습니다. 특히 저희는 2021년 서타라사와 국내 디스트리뷰터 계약을 체결하고 서타라사의 제품들을 국내 소개 및 판매하고 있습니다. 서타라사는 전 세계 11개 규제기관 및 1,600개 이상의 글로벌 제약회사들을 고객으로 하고 있고요. 또 바이오 시뮬레이션 소프트웨어 및 기술 지원을 통해서 고객 중 90% 이상이 성공적으로 승인을 받도록 한 사례들을 가지고 있습니다. 서타라사에 대해서 더 자세한 내용들은 뒤에서 좀 더 설명을 드릴 수 있도록 하겠습니다. 오늘은 서타라사의 피닉스 플랫폼에 대해서 설명을 드리는 시간을 가져보려고 하는데요. 먼저 저희 바이테캠스와 서타라사에 대해서 간략히 소개를 드릴 예정인데 이미 저희 바이테캠스에 대해서는 설명을 드렸고 제 설명이 끝난 후에 서타라 한국지사의 이준용 이사님이 서타라에 대해서 설명을 해주실 예정입니다. 그 다음에 윈놀린 NLME 밸리데이션 스위트 제품에 대해서 설명을 드린 후에 Q&A 시간을 가질 예정입니다. 시간 관계상 아마 Q&A 시간에 질문해 주신 모든 사항에 대해서 답변을 드리기는 어려울 것으로 예상이 되고요. 하지만 오늘 답변 드리지 못한 부분은 추후 이메일을 통해서 답변을 드릴 예정이니 궁금한 점이 있으시면 무엇이든지 질문을 해 주시길 바라겠습니다. 문의사항은 아마 질문창에다 작성을 해주시면 될 겁니다. 혹시 오늘 웨비나 내용 외에도 더 궁금한 점이 있으시다면 추후에 저에게 연락을 해주시면 저희 바이테캠스가 최대한 지원을 하도록 하겠습니다. 자, 그러면 서타라사 한국지사의 이준용 이사님에게 서타라에 대해서 좀 들어보도록 하겠습니다.
예, 안녕하세요. 서타라 코리아의 이준용입니다. 이미 그 서타라에 대해서는 사실 서타라의 피닉스 플랫폼에 대해서는 많은 분들이 잘 알고 계실 것 같고요. 서타라는 이제 한국에는 지사가 올해 22년부터 정상적으로 이제 런칭을 해서 여러 고객들의 어떤 기대치나 또는 고객들의 보이스 그리고 특히나 한국 시장의 바이오 벤처나 여러 제약사분들이 이제 미국 시장이나 또는 글로벌로 진출하시려는 이런 요청들이 많이 있으셔서 한국에 이제 22년부터 서타라 지사를 시작을 하게 되었고요. 예, 그래서 저도 지금 최근에 가장 바쁘게 움직이는 게 많은 고객분들을 만나고 보이스를 듣는 부분들을 좀 많이 하려 하고 있습니다. 오늘 제가 서타라에 대해서 좀 말씀드릴 내용은 서타라가 무슨 회사인지 그리고 어떠한 부분을 커버를 하고 있는지 피닉스뿐만 아니라 여러 영역들이 있고요. 또한 후에 이제 피닉스에 대한 짧은 소개를 마무리함으로써 저희 이제 본 패널인 그 크리스 멜의 피닉스에 대한 윈논린과 NLME 그리고 밸리데이션 스윗에 대한 부분들을 말씀드리는 시간을 가질 수 있도록 하겠습니다. 예, 본 웨비나는 그 실제 이제 90분짜리로 계획이 되어 있고요. 넉넉하게 시간을 준비했지만 Q&A나 이런 시간에 따라서 좀 더 일찍 끝날 수 있다는 점 참고를 부탁드리고 기본적으로는 모든 그 고객분들, 참석자분들은 더 뮤트 상태이십니다. 그래서 질문이 있거나 이런 부분들이 있으시면 그 왼쪽에 보이시는 그 물음표 박스를 눌러서 질문을 언제든지 해주시면 저희가 가능한 최대한 빠르게 답변을 드릴 수 있도록 하겠습니다. 또한 끝나고서라도 서베이가 이제 진행이 될 예정인데 거기에서도 여러 가지 요청사항이나 또는 추가적인 질문을 해주셔도 언제든지 좋습니다. 예, 간단히 그 서타라에 대해서 말씀을 드리면 서타라는 아까 짧게 말씀을 드리긴 했지만 글로벌하게 2000여 개 고객사가 있습니다. 이 중에서 좀 흥미로운 점은 이런 여러 가지 이 신약 개발과 그다음에 이 제약사 이 산업 쪽에 지원하는 여러 가지 테크놀로지 벤더들이 있는데 그 중에서 서타라가 가지는 가장 큰 장점은 또는 흥미로운 점은 여러 글로벌 그 유수 규제 기관들이 다 고객사로 있다는 것입니다. 그래서 글로벌하게 17개 고객사가 있고요. 그러한 부분들 때문에 글로벌 탑 30파마가 현재 서타라 플랫폼과 장기적으로 10년 이상의 장기적인 파트너십을 가져가면서 사용을 하고 있습니다. 또한 이제 그 2014년부터 FDA에 승인받은 노벨 드러그 신약의 90% 이상이 서타라 플랫폼에서 개발됐다는 어떤 흥미로운 통계가 있고요. 뿐만 아니라 이제 1200명 직원이 있는데 그 중에 이제 350명 이상의 직원들이 PhD, PharmD, MD로 이런 전문 인력들로 구성이 돼 있어서 단순 기술적인 부분뿐만 아니라 메디컬적인 또는 통계적인 이런 관점에서 이러한 전문적인 역량을 지원을 하고 있습니다. 실제 이제 이 서타라나 이런 부분들의 어떤 이 글로벌 풋프린트를 좀 말씀드리면 본사는 뉴저지의 프린스턴에 있고 미국과 유럽에 상당히 많은 어떤 사이트 지원 인력들이 있고요. 또한 이제 아시아에는 호주랑 일본, 서울, 중국 등등 여러 글로벌 아시아 고객들이 이제 이런 부분들을 많이 지원을 하고 있습니다. 아까 말씀드렸다시피 이제 1200명 직원 중에 그 실제 이제 그 직원들의 분포 또는 지원 인력들의 분포를 보면 아시아 쪽이 지금 상대적으로 상당히 빨리 성장을 하고 있어서 현재는 이제 거의 한 300명 가까이 되는 걸로 이해를 하고 있고 또한 이제 아까 말씀드렸던 전문 인력들이 매년 그 과학적인 논문을 제출을 하고 또 선정이 되고 있습니다. 그 중에 한 2%, 7명 정도가 상당히 좀 권위 있는 어떤 이 논문 발표로 좀 인정을 받고 있고요. 아까 말씀드렸던 이제 서타라에 대한 회사 소개를 좀 약간 이제 좀 더 딥다이브하게 내려와서 서타라가 그럼 어떤 영역의 제품을 가지고 있고 어떠한 플랫폼을 가지고 있는지 좀 간단하게 말씀드리면 왼쪽에 보이는 왼쪽의 노란색 부분은 드러그 물질을 찾는 드러그 디스커버리와 바이오 시뮬레이션 이런 영역들이 있고 이제 전임상을 다 마치시고 난 뒤에 휴먼 바디로 들어가게 되는 클리닉의 마켓 액세스 이런 영역들 크게 두 파트가 있습니다. 그래서 오늘 좀 주요하게 말씀드릴 내용인 피닉스 그다음에 뭐 한 번쯤은 들어보셨을 뻔한 심시프 그리고 아마 오늘 참석하신 분 중에 좀 관련이 있을 수도 있는데 이 전임상 쪽에 이제 샌드 데이터를 어떻게 잘 관리하는지가 사실 이제 가장 그 미국으로 가시는 중요한 어떤 길목에 있는 부분들인데 그런 샌드 관련된 부분들 뿐만 아니라 향후에 이제 클리니컬 쪽으로 가시게 되면 이제 관심들이 있으실 것 같고요. 실제 이제 오늘 말씀드릴 피닉스 그리고 물질을 찾아주는 D360 이런 부분들은 이제 한국 시장에서 지금 상당히 많은 관심도가 있으신 제품들이고 이러한 부분들이 왜 계속해서 한국 시장이나 또는 글로벌 규제 기관들에서 이제 많이 활용이 되냐라는 부분들을 저희가 봤을 때 실제 아까 서두에서 말씀을 드렸지만 서타라의 그 가장 큰 그 장점과 경험치 중에 하나가 규제 기관들이 내부의 분석과 내부의 아날리시스 분석 그리고 판단하는 데에 사용되는 플랫폼을 서타라 플랫폼을 이용을 하고 있습니다. 그래서 저희가 과거에도 뭐 FDA와 여러 가지 프로젝트를 많이 했지만 현재 2018년부터 지금 FDA에 500명 이상의 교육들을 지원을 하고 FDA 스태프들이 이런 서타라의 피닉스라든가 또는 여러 가지 플랫폼도 실제 업무나 판단을 하고 있고요. 그래서 그 서타라에 가지고 있는 여러 플랫폼들 아까 보여드렸던 플랫폼 중에 어떠한 부분들이 FDA에서 활용이 되고 있나 살짝 마크를 해봤습니다. 그래서 오늘 말씀드린 FDA 피닉스뿐만 아니라 심시, 샌드 익스플로러, 피나클 20, 글로벌 서밋 등등 대부분의 프로덕트 제품들이 FDA에서 내부 업무를 위해서 이미 활용을 하고 있고 또한 서타라에 있는 여러 가지 기술 지원 컨설팅 팀들이 온사이트로 상주를 하면서 이런 FDA의 기술적인 지원을 하고 있습니다. 그래서 오늘 말씀드릴 내용은 빨간색 박스로 이제 마크업된 피닉스에 대해서 말씀을 드릴 예정이고요. 피닉스는 뭐 이미 잘 아시겠지만 인더스트리의 골드 스탠다드 플랫폼으로서 골드 스탠다드라고 하면 거의 시장 점유율 90% 이상 하고 있기 때문에 이 FDA뿐만 아니라 여러 글로벌 규제기관 검증되어 있는 그러한 어떤 플랫폼이라고 보시면 좋을 것 같습니다. 그래서 서타라의 방향성은 기본적으로 이런 플랫폼들을 제공을 하매 이 규제기관들이 내부에서 여러 가지 분석과 또는 이제 의사결정을 하는데 쓰는 플랫폼이기 때문에 이러한 플랫폼들을 우리 시장의 고객분들에게 동일한 방향성으로 규제기관이 보고 판단하는 기준을 최대한 동일한 수준으로 고객분들이 그들의 고객분들의 데이터를 판단하고 분석하고 의사결정할 수 있게 도와주자라는 부분들이라고 보시면 좋을 것 같고요. 그래서 피닉스에 대해서 짧게 말씀을 드리면 피닉스는 이미 잘 아시다시피 가장 코어인 윈논린에 있습니다. 윈논린을 주변으로 NLM이라든가 밸리데이션 수이라든가 IBIC, 인티그럴, PK 서밋 등 다양한 수입 제품들이 있습니다. 사실 윈논린이 한국 시장에서는 거의 이제 대폭적으로 많이 사용이 되고 있는데 최근에는 미국 시장을 진출하기 위해서 여러 가지 필수 불가결한 어떤 요구사항들이 있고 그런 부분들 때문에 다양한 수입들에 대한 어떤 문의들이 많이 오고 있는 현실입니다. 실제 이제 피닉스 플랫폼은 글로벌하게 2,600개의 고객사가 이상이 사용을 하고 있으며 탑 20 제약사가 모두 사용을 하고 있습니다. 또한 이제 아까 말씀드렸다시피 이제 글로벌리 이제 레귤레터리가 이제 11개의 규제기관에서 이미 활용을 하고 있고 국내에는 이미 120여 개의 고객사가 사용 중에 있습니다. 말씀드렸다시피 미국의 US FDA를 기반으로 여러 국가, 유럽, 그 다음에 브라질, 그 다음에 아시아 쪽에는 중국, 일본, 한국, 그 다음에 태국뿐만 아니라 호주 등등 글로벌리 많은 그 선진 규제기관들이 이 피닉스 플랫폼을 이용해서 PKPD 또는 이제 PAPK 등등에 대한 어떤 판단을 지금 내부 분석을 용도로 활용을 하고 있다고 보시면 좋을 것 같고요. 실제 FDA 같은 경우에는 2005년부터 피닉스를 전사적으로 도입을 했습니다. 이런 PKPD나 뿐만 아니라 NLME, 그다음 Population PK, 그다음 IVIC, 그 외에도 피라나 트라이 시뮬레이터, 그다음에 PK 서밋 등등 다양한 제품들을 효율적인 어떤 판단과 의사결정을 위해서 2005년부터 쓰기 시작을 했고, 아까 말씀드렸다시피 서타라는 FDA의 여러 그 내부 스태퍼들을 교육을 지속적으로 해왔습니다. 그래서 현재는 지금 480명의 FDA 어떤 심사관들이 이런 부분들을 활용을 하고 있고요. 또한 11개 피닉스, 11개의 FDA 부서에서 피닉스를 활용하고 있습니다. 그래서 오늘 말씀드릴 내용들은 사실 이제 피닉스에 여러 모듈들이 있지만 좀 시간 관계상 오늘은 3가지 모듈로 추락을 했습니다. 그래서 실제 이제 오늘 말씀드릴 피닉스의 첫 번째 모듈은 윈논린. 이미 잘 알고 계시는 부분이겠지만 Non-Compartmental Analysis와 BioEquivalence, PKPD 모두 등에서 거의 업계에서 많은 부분도 활용이 되는 부분들이고요. 그 외에도 NLM이라고 해서 이제 실제 이제 논리니어 모델링 시뮬레이션 모델링을 통해서 population PK에 활용을 하신다거나 좀 PD에 활용하시는 부분들에 대한 부분들을 좀 말씀을 드릴 내용이고, 네 번째로는 제가 오늘 말씀드릴 내용이 validation입니다. 최근에 가장 좀 주요하게 많은 부분들 문의가 있으신 부분 중에 하나인데 저도 이 서타라에 조인을 하고 나서 좀 이제 알게 된 사실 중에 하나인데, 많은 고객사분들 중에서 이 미국 시장에 진출하기 위해서 가장 좀 챙기셔야 되고 또 미리 체크하셔야 되고 유념하셔야 되는 부분 중에 하나가 소프트웨어 밸리데이션 부분인데, 이 부분은 미국 FDA의 21 CF 파트 11의 명시가 요구사항입니다. 근데 이런 부분들이 아직까지 국내 시장에 몇몇 고객사분들이 모르시는 부분들이 좀 있으셔서 최근에 이런 부분들을 이제 알게 되시고 빠르게 도입을 좀 검토하고 계신 부분 중에 하나라고 보시면 좋을 것 같고요. 실제 이러한 부분들이 피닉스가 아까 말씀드린 여러 모듈들이 있는데 디스커버리에 따라 있는 D360을 출발을 시작을 해서 프리클리니컬 페이스 1, 페이스 2 뿐만 아니라 파마코메트릭에서 이제 파피케를 하시게 되면 페이스 1, 2, 3에서 이런 부분들을 많은 부분들을 활용하실 수 있다고 보시면 좋을 것 같습니다. 마지막으로 저는 이제 그 아까 말씀드렸던 밸리데이션에 관련된 어떤 요구사항이 무엇이냐라고 문의를 주시는 고객분들은 상당히 많이 있어서 FDA의 21 CF 파트 11의 그 전자 시스템 규정에 보면 어떠한 시스템을 사용하는 경우에는 모두 컴퓨터라이즈 시스템에 대한 밸리데이션을 하셔야 된다는 어떤 규정 조항이 있고요. 그래서 FDA가 어떠한 방식으로 하라는지 그런 디테일한 방식들은 정확하게 규정으로 가지고 있지는 않지만 시스템의 밸리데이션 해야 된다는 것은 명확하게 가지고 있습니다. 그래서 그 어프로치를 보게 되면 노란색으로 되어 있는 부분, 그 리스크 어세스먼트를 하시거나 또는 이제 이런 것들을 다큐멘테이션으로 잘 정리를 해 놓으셔야 되고, 또한 이제 이러한 시스템들이 재현 가능한지 그러니까 A라는 데이터를 넣으면 B가 나와야 되는데 이런 것들이 재현 가능한 시스템으로 밸리데이션 되는지, 또한 이 데이터들의 어떤 무결성을 보장할 수 있는지, 여러 가지 관점에서 이런 밸리데이션을 해야 된다는 부분들이 있습니다. 실제 이제 윈논린 같은 경우에는 이런 시스템들을 데이터를 이제 활용하심에 있어서 분석하고 의사결정하시는 데 활용할 수 있지만, 이러한 이 21 CF 파트 11에 준하는 요구사항들을 밸리데이션 하기 위해서는 자체적으로 하실 수도 있겠지만, 또한 자체적으로 하실 수 없다라고 하면 저희 이 밸리데이션 스윗을 활용을 하시게 되면 상당히 간편하고 검증된 방법으로 바로 이런 FDA 요구사항들에 준수할 수 있게 됩니다. 그래서 향후에 이어질 어떤 슬라이드에서 영상에서 밸리데이션 스윗에 대한 좀 더 내용을 들으시면 좋을 것 같고요. 저는 오늘까지 여기까지 준비한 내용을 말씀을 드리고 다음 발표로 넘기도록 하겠습니다. 감사합니다. Amy, can you please continue?
Thank you, Julian. Hi, everyone. We will connect with Chris, so please wait a second. Thank you.
잠시만 기다려 주시면 영상이 곧 재생될 예정입니다.
I'm the product manager for the pharmacokinetics software offered by Certara. That does include the Phoenix platform, and the components of it that I'd like to talk about today are WinNonlin, NLME, and the validation suite. So I'll begin with talking about what is Phoenix. So Certara's Phoenix platform is the leading PK/PD modeling and simulation software used worldwide by over 6,000 researchers at biopharmaceutical companies, academic institutions, and global regulatory agencies such as 11 divisions of the US FDA. Phoenix extends the winning formula of WinNonlin by combining its trusted algorithms with built-in, easy-to-use graphical user interface and a textual editor for advanced analysis. Phoenix 8.3 offers features that support compliance and efficiency, including visual workflows that can be used and reused, locked to maintain compliance, and these workflows increase efficiency and also are able to produce reports. It produces high-quality tables and figures, and is also compatible with CDISC. So if you have CDISC SDTM for clinical or send data for non-clinical, that type of data preparation can be done in the Phoenix platform. And Phoenix has a project-centric design to easily store, share, and reuse Phoenix projects. Phoenix also has a fully integrated validation suite for fast automated software validation in under 30 minutes. So conceptually, what Phoenix is an operating platform. It's got a single user interface with a look and feel. So the single user interface has several different modules to it. It includes WinNonlin, which is used to perform individual PK/PD modeling, non-compartmental analysis, and bioequivalence analysis. The IVIVC toolkit, which is used to do in vitro, in vivo correlation analysis that is used in formulation development. Phoenix also has an NLME, which stands for Nonlinear Mixed Effects module, which is used to perform population PK/PD analyses. The Phoenix platform also has a validation suite that's used to perform fast automated validation for WinNonlin and or NLME. Additional plugins that are available include CDISC and the PK Submit plugin, which is used to get non-compartmental analysis results into a CDISC compliant format. Lastly, we have a secure central data repository called Integral, which Phoenix can connect to pull in data for analysis, run the analysis, and then save back in a manner that is used to achieve 21 CFR Part 11 compliance. So all of these different modules are in a unified user interface that has the same look and feel. So it's very easy to go between the different modules. The Phoenix platform has a large array of useful tools that span the PK/PD analysis spectrum. These include system tools, such as a workflow. A workflow is a series of steps that one uses to go from raw data, prep data for analysis, run modeling and simulation, and then tabulate results. That series of steps is a workflow. And it also supports data links, so you could make a template of your workflow and pipe new data in and run it through the same workflow steps for the types of studies that you would repeat often. There are also a variety of data prep tools, such as CDISC data preparation and various spreadsheet operations, such as append worksheets, cross-product worksheets, data wizards for doing transformations, merging and joining worksheets, pivoting worksheets, and so on. There are also a variety of plotting tools available in Phoenix, and these include typical scientific plots such as bar plots, column plots, histograms, XY scatter plots matrix, and categorical XY. Okay, so additional tools that Phoenix has from the analysis perspective, probably the most commonly used tool in the Phoenix platform is the non-compartmental analysis tool. It's used very commonly in preclinical or clinical studies, but primarily preclinical. We also have a BioEquivalence analysis tool and several other analysis tools, descriptive stats, non-parametric superposition, and so on. There are also a series of compartmental PK/PD modeling tools. So they include PK and PD compartment models, PK/PD link models, Michaelis-Menten models, linear models, and indirect response models. One can also do dissolution models for formulation development. We also have a very flexible Phoenix model. The Phoenix model is a maximum likelihood modeling engine that can be used to perform either individual or population PK/PD analyses. And there's a very handy model comparer tool, which can be used to compare objective functions and other diagnostic outputs from various models that will help guide model selection. Okay. Phoenix also has some reporting tools. It has a table module that allows one to construct a report table, tabulating results in a very easy to read format. Different layouts are supported, including summary statistics. And there's also a reporter tool, which one can use to selectively pull outputs from your Phoenix project and assemble them into a presentation quality report, complete with figuring and legending and captions and footnotes and the like. The Phoenix platform can also be used to integrate with third-party softwares, such as NonMem, SAS, SigmaPlot, PearlSpeak's NonMem, and R. A relatively new feature in the Phoenix platform is the ratios and differences tool. So very commonly in these types of studies, in various studies, one might want to compare PK parameters from different routes of administration or from different dosing regimens, parent metabolite, and so on. So this ratios and differences tool was added to very easily support studies such as average renal clearance when you have plasma and urine data, accumulation ratios for multiple dosing studies, demographic comparisons such as gender differences, parent to metabolite exposure ratios, dose proportionality, as well as exposure ratios for topics such as food effect, drug-drug interactions, and relative bioavailability. So the user interface for Phoenix, the diagram here is essentially showing a workflow that allows you to visualize the series of steps that go from raw data all the way through analysis and to the final result. So as an example here, you might have an input data set that pipes in through a data link, maybe do some exploratory plots, such as a concentration versus time plot by subject and analyte, maybe make a table of individual concentrations and mean concentrations with descriptive stats. From there, after doing that exploratory work, perhaps run a non-compartmental analysis to compute PK parameters, and then make a summary of those parameters in the form of either descriptive stats or a table. So this series of steps allows one in a workflow to get from the raw data all the way through to the endpoints. Okay, so that's the Phoenix platform. What is WinNonlin? So WinNonlin is the industry standard for non-compartmental analysis and PK/PD modeling and simulation. Phoenix WinNonlin has been around for over 30 years and is used by thousands of scientists in over 60 countries, including top pharmaceutical companies and academic institutes. And we also have Phoenix made available to several regulatory agencies around the world, including the US FDA, Japan's PMDA, the China Food and Drug Administration, and UK Medicines and Healthcare Products Regulatory Agency. And all of these organizations have Phoenix WinNonlin available to evaluate drug submissions. So WinNonlin, the WinNonlin component of Phoenix, supports non-compartmental analysis and individual PK/PD modeling, as well as a variety of statistical analysis tools for a wide range of studies and analyses, as I alluded to in the previous slide. The NCA engine automatically outputs additional parameters for plasma and urine to save time, reduce errors, and produce higher transparency for regulatory agencies. It is possible to set strict criteria for NCA, the acceptability of results. We call those business rules, as well as to compute user-defined parameters for the NCA. It's also very easy to calculate the NCA parameter ratios, which increases efficiency and saves time. For early non-clinical research to large clinical trials, the NCA engine and statistical analysis tools can be used in single, multiple, or steady state dosing studies, drug concentration in plasma or urine, sparse sampling studies, as well as toxicokinetic studies, pharmacodynamics data, formulation comparison, first in human dosing, single and multiple ascending dose, drug-drug interactions, and bioequivalence studies. I just wanted to point out, again, we do have collaboration with regulatory agencies such as FDA that allows the FDA to provide input and work with us to optimize the software. So one of those types of collaborations, this is a poster from AAPS. And so we worked with the FDA to create a workflow template that performs reference scaled average bioequivalence. And we have templates for the progesterone guidance. That's kind of the baseline reference scaled average bioequivalence. But typically these reference scaling is done when the drug has high intrasubject variability. So it's important to be able to scale the confidence limits and adapt the standard confidence intervals for bioequivalence. And this particular example I'm showing was from the warfarin narrow therapeutic index drug study. And it shows how we were able to make a workflow template to satisfy all the criteria from the guidance. Okay. As far as Phoenix WinNonlin is concerned, just to get an idea of how often we release new versions. So Phoenix first appeared in June of 2009, and we typically release a new point version about every 1 to 1.5 years. In the Phoenix 8.3 series, we did a series of maintenance releases, but we're also working toward a Phoenix 8.4 release. So it is an active live software that is continuing to be improved and developed over time. I did want to allude to the fact that Certara does take a proactive approach to engage our customer base for ideas about product improvements and enhancements. These include live surveys during webinar series, user group meetings, client visits, training courses, as well as user forums. A summary of the key features in the WinNonlin 8 series will be shown in the software demonstration. Okay. So with that, I would like to go ahead and pause the slides here and move into the Phoenix application and have a look at it. Okay. So what I'm showing here is the Phoenix application. I'm going to show an example project. I'll start with the data set. So in this data set, we have a series of PK data in an input spreadsheet. And this spreadsheet has all of the data of a given type in a column. So all of the subject IDs are in one column. All of the formulation names, such as Tapsler or Cablet, are in a second column. The times of the observations are in a third column, and then the concentrations in nanograms per milliliter are reported in a fourth column. So just to show, kind of an example workflow, what one might do is send this data set to an exploratory plot. Perhaps plot the individual subjects and group by formulation. So for subject 1, if this is a crossover study where each subject got 2 different formulations, you can see the capsule data and the tablet data plotted for subject 1, and then toggle between the different subjects on different pages. A second plot would be to overlay by formulation. So in this case, on each page, we have a different formulation. So page 1 would be the capsule data for all subjects, and page 2 would be the tablet data for all subjects. And these are plotted on a semi-log scale with the log of the concentration on the y-axis and the time on the x-axis. From there, the user could go to the non-compartmental analysis tool, and every tool has a setup area. So in the setup area, that's where you define what data type each column is. So you can map the time and concentration columns and the profiling columns, such as subject and formulation, that will run a separate NCA analysis for each combination of subject and formulation. There's also an easy-to-use dosing input where you can enter the dosing information for each subject. There's also a graphical slope selector that can be used to select the terminal slope for each individual profile. There is a default best fit algorithm, but it's also possible to specify a time range for the terminal phase. So those are some key features. A couple other items here is that you can set, it's good at unit handling. So you can take units from the input data set and maybe convert them to some preferred units for your output table if desired. Let's say you wanted concentrations in micrograms instead of nanograms, or doses in milligrams instead of nanograms. It's very straightforward to do that here. You can also see the parameter name list. This is a list of all of the output parameters that come from NCA. And you can, they have default names, but you can also specify your own preferred names in that, as well as toggle whether or not to include each parameter in the workbook result. Once the non-compartmental analysis is run, you get several outputs. I'll start with the plotting output. The plot will show on a profile by profile basis the terminal phase, which is done by a log linear regression of the points toward the end of the profile. That's represented by the green regression line shown on the plot. And that's used to compute parameters such as adjusted R-squared, as well as the half-life. In the final parameters pivoted output, you get a table that shows a listing from left to right of the subject, formulation, and then associated PK parameters. So I alluded to the half-life here. You also get the typical parameters such as Cmax, AUC, AUC infinity, AUC percent extrapolated, volume of distribution, clearance, and so on. So it's very easy to take this result worksheet and then put it into other items such as a table. So if I wanted to tabulate and summarize key PK parameters from this study, I would set up a table. The table does have a setup interface that allows you to construct different layouts for how you want to present the data. They do include precision, so you can toggle between, say, for example, significant digits and or decimal places, and how many of each you want, as well as the ability to include summary statistics in an easy-to-use checklist for inclusion in the table. Once you run the table, in this result, I set it up so that there's a page break on the formulations. So this first table toward the top is all about the capsule formulation. There's a vertical listing of the subject IDs, and then the key PK parameters Cmax, Tmax, half-life, AUC last, and AUC infinity. Notice that these are formatted to 3 significant digits. For the AUC and concentrations, for the time parameters, they're formatted to 2 decimal places. And then the summary statistics are shown in bold below each column. And then the same layout is also used for the tablet formulation. So the exact same formatting. You can also do advanced formatting such as superscripting and subscripting parts of the name, using different symbols such as the Greek alphabet and the infinity symbol, and so on. From there, if you have enough results in your report, in your project that you may want to report them, you can send the results to the reporter tool. So the reporter tool has an interface that allows you to pick selected outputs. So maybe this is the grouping of exploratory plots. This is the a second set of exploratory plots. And again, this is just the setup preview. It's not the actual report. But you can also do things like take your lambda z result plots, final parameter table, as well as the table that was constructed earlier in the workflow. And you have also different options for captioning using major and minor indices to give figure numbers, and toggle whether the output format is in Word, PDF, or both. And also identify whether you want to include footnotes, such as the date timestamp of when the analysis was run, what is the source, and the object name. But once you run the table, you can get the results in either a Word format, such as here. So this is an example in the Microsoft Word format. It shows all of the exploratory plots in both linear and log format in a lattice. You can also look at the additional outputs, such as the final parameters listing, all the way down to the summary tables at the bottom. And notice that the effect of the page break, it tabled them out into table 1.2 for the capsule and table 1.3 for the tablet. So that's the Word format, and you can also get it in PDF format as well. It's kind of nice and easy to navigate as well in the PDF format. So whichever format you prefer, I can jump to the end here for the PDF. This reporting tool is part of the Phoenix platform. So that's just an example workflow. I did want to introduce also the topic of ratios and differences. So finishing up with this particular project, I'm going to go to the non-compartmental analysis and just show some basic items that were set up here. So on this particular NCA, I set up a rule that required that for final parameters to be accepted, they must have an adjusted R-square value of greater than or equal to 0.98, and that the AUC percent extrapolated must be less than or equal to 20%. And so what ends up happening when you set up these business rules is you get these flags in the output. So for the R-squared adjusted, we see an example here. Here's R-squared adjusted. It will go through and it will find any, for example, this one is less than 0.98, and it doesn't filter it out, but what it does is it makes a flag column that says whether it's accepted or not accepted per the business rule criteria. And from there, you can use that flag column to, if you want to filter out those parameters, you can use a data wizard as an example to filter, basically essentially filter where the flag is not accepted. And then in the results, you see which records were filtered out, all those that were not accepted are filtered out, and all those that were accepted remain in the results. So that's just a base example of some business rules. I did want to show a further example of that. So with these business rules here, you can do things like LLLQ replacements. So that's done via this BQL tool, where you can identify when do you replace the LLLQs. So this is the original values. And early in the profile, you might want to replace BQL with 0. Later in the profile, you might want to replace it with missing, as an example. So those replacements can be done. And then in the business rules of the NCA, you can specify things like the rules including span. If the span parameter is the number of half-lives, so this business rule is saying the profile must have a span of at least one half-life in order to be valid. And then the data tools can also be used to support advanced reporting tables, such as this is an example of PK parameters with stats in the body. So if you want to show the mean Cmax plus or minus, the standard deviation or other PK parameters, these types of tables can be composed with a combination of data tools and the reporting tool. Here's one other example. If you get the table and you want mean concentrations instead of PK parameters, this is a listing of the actual concentrations by nominal time, with reporting the concentrations for capsule and tablet at each time point, with the mean plus or minus standard deviation with the CV percent reported. So advanced tables can be constructed. And then I'd like to show one more example here, and that is going to be the ratios and differences tool that I alluded to in the slides. So in this case, we have a large data set. This is from a toxicokinetic study, and there are different routes of administration, different matrices, gender information such as females and males, different routes of administration, as well as different analytes such as parent and metabolite. So this might be test analyte, and then 4-hydroxy-TA is the metabolite. And so that supports different ratios such as dose proportionality. So there's different dose levels. There's a 1 mg per kg, 10 mg per kg, and 60 mg per kg. So you might want to look at dose proportionality and see if the scaling is linear across dose groups. And then you might want to look at the result and get these ratios. So maybe the Cmax of the 10 milligram compared to 1, the Cmax ratio of the 60 compared to 1, and same ratios for AUCs as well. You can also look at things such as accumulation ratio. So in this case, we're comparing day 14 to day 1. So there's a day column here that identifies the day, and then you can set up the ratio in this bottom panel and come up with ratios, accumulation ratios comparing day 14 to day 1. And you can also very easily do these for gender differences. So that would be this unstacked gender differences, Cmax ratio, female to male, AUC last, female to male, as well as parent to metabolite ratios. So if you wanted to compare parameters, parent to metabolite, you can very easily set these up as well. So this is a very handy tool for different types of study types. The core of this is the NCA, or non-compartmental analysis. And from there, a variety of easy to use data tools can really help you get the most out of your NCA. Okay, so that's Phoenix WinNonlin. At this point, I'd like to switch back and introduce the topic of NLME. So this is another module in Phoenix. NLME stands for Nonlinear Mixed Effects Modeling. NLME is used to perform population PK/PD analysis, and the aim is to expand a PK/PD model to account for sources of variability in key model parameters between subjects in a population. These are things, the questions that can be answered by POP modeling include things like, does a drug's clearance increase with the age of the subject? Does volume of distribution vary with body weight? Is there a significant difference between sexes for any important model parameters, and so on? So a good population PK/PD model will not only describe PK/PD outcomes in the population being studied, but will identify key demographics, also called covariates, that can be used to produce PK/PD outcomes in a different population of subjects. So study types where one might use NLME include therapeutic drug monitoring, pharmacometrics, PK/PD and PK/PD link models, physiology-based PK models, also known as PBPK, disease progression models, and they're also an important prerequisite for clinical trial simulations. So some key features of Phoenix NLME include different modeling algorithms. So that, kind of the base or simplest algorithm that one might use early on is the naive pooled, where you can do individual or pooled data analysis. And then there's also modeling engines that include parametric methods such as first order conditional, Lindstrom-Bates, and extended least squares, iterative two-stage, Laplacian, as well as QRPEM. The QRPEM is a PEM method, and it's a very advanced method that won a modeling algorithm contest at Page in 2012. So QRPEM was found to be consistently the fastest to converge among the expectation maximization, or EM methods, demonstrating the advantage of this approach. Also, in population analysis, stages to it. So first, model fitting, developing a structural model as well as a residual error model. That can be done in the simple mode. And then when one goes to find covariates that may be significant, there are covariate search methods. They include Okay, apologies for the delay there. I lost my Wi-Fi briefly, but I'm back now. So I was showing the key features. So I'll start on this bottom portion. When you're doing population model fitting, the simple run mode can do things like help you build the structural model and identify the best structural model, as well as the residual error model. There are covariate search methods available, such as the stepwise approach that can be conducted in either the forward or backward direction. Shotgun approach, if you have a large number of covariates and you just want to kind of look at large numbers of combinations of them, that's available, as well as scenarios where you handpick different covariates and include them in a model fitting scenario. When it comes to model validation, the standard methods are available. One can do bootstrapping, profiling, as well as visual predictive checks. And it's also possible to take the population PK/PD modeling results and run simulations based off of them. Okay, so that's the Phoenix NLME. I'd like to go back into the Phoenix software and go ahead and show that feature. So this is a population PK/PD analysis conducted based on phenobarbital in infants. So we start with an exploratory data analysis. So this is the PK data for all of the subjects. From there, one might perform a naive pooled analysis to compute some parameters and help develop a structural model. So in this case, on the structure tab, if it's an intravenous route of administration, you can select that here in the absorption route, whether it's IV or extravascular, whether the parameterization of the model is micro, macro, or clearance, the number of compartments, and so on. And when you make these different menu selections, it actually creates what's called a model text that can be further customized if needed. For the most part, you wouldn't need to do this, but it's an option that's available if you want to further tweak your model. But typically from there, one would go on to model development, development of a population base model. So in this case, what you could do is add some different covariates to the model. This is from the input data set, such as in this case, we have body weight and APGAR score, and those can be added to the model. And you can also identify the covariate type, whether the variable is continuous, categorical, or occasion. On the fixed effects tab, you can supply initial estimates for the parameters. And then when it comes to the model fitting, the theta worksheet will show the estimates for volume and clearance. Those are the key parameters in the study, as well as the outputs, such as the the population fit of the predicted versus observed on the data. You also get a series of residuals. These are residual plots versus time. So your goodness of fit plots, residual versus predicted, as well as ADA histograms, which will help you, tease out which covariates might be significant, as well as the population covariate plots. So you might notice a covariate that might appear to be highly correlated. For example, volume and body weight. Looks like a very strong correlation there. So you might want to run some type of a scenario where you factor in the effect that weight has on volume of distribution as part of your population model. The covariate search, so again, what I just showed you here in terms of the modeling mode, I'm in the simple modeling mode where I'm working on building my model. And then the covariate search methods can be used to help identify covariates. So in the stepwise covariate search, you can run that through and it will try adding different covariates on different model parameters and see the relative improvement of the objective function. Available objective functions include -2 log likelihood, Akaike, and Schwartz criteria. When you actually go ahead and run this, it will run a series of different combinations. So we'll try volume on weight, clearance on weight, volume on APGAR, clearance on APGAR, and different combinations. And it will actually identify which one had the best overall objective function. And you can set thresholds for what's acceptable. So in this case, it's using -2 log likelihood to evaluate whether the scenario has improved, and the significance level using p-value. So using that, this tool arrived at volume on weight and clearance on weight as the best population model. You can also do scenarios and shotgun. In the interest of time, I'm not going to go through the details of those, but just knowing that those are available as covariate search methods. You can also evaluate covariance. So covariance is if you think one or more relationships might be correlated. So on here, on the random effects tab, you can set the variance terms for the eta for volume, eta for clearance, as well as correlation between those two etas, this off-diagonal term. So you can either do diagonal or off-diagonal terms and incorporate that in the model. Next, once you have a model that looks like it's pretty good, maybe evaluate the results and see that you've got good parameter estimates. Notice that we have the effect of change in weight on change in volume. The effect of change in weight on change in clearance are now included in parameters of the model. Our coefficients of variation in this case are very good. They're all less than 20%. So one might at this point say, okay, I think I've got a good model here, but is it good enough? And move on to model validation. And that can be done by bootstrapping and visual predictive check typically. So the bootstrap is a run option mode that's available in Phoenix. So that's in this run options tab. You can specify bootstrap as well as the number of replicates you want to run in your bootstrap. And it will give you an output that shows the results of the bootstrap. So you have boot theta, and you want to see if you keep rerunning this bootstrap maybe 1,000 times, if your original model fits within the 95% confidence interval from the bootstrap that was done by resampling all of the subjects. In addition to that, there's also a visual predictive check tool. So the VPC is another tool used for model validation. It's a highly visual method that's very easy to interpret. So you see the population model and the observed and predicted quantiles of 5%, 50%, and 95%, as well as the confidence bands associated with those quantiles. So this is kind of your classic VPC, where you see the median, which is associated with the 50% quantile, and then the upper, which is the 95%, and the lower band, which is the 5%. And then from there, if you wanted to run take this model, if the VPC passes and you want to take this model and then run simulations, you could, for example, simulate different dosing regimens or simulate a different population, as long as you know that population's weight and APGAR score in this case. So this is, say, a multiple dose simulation based on the population model. Okay, so that's Phoenix NLME. I'd like to talk about one other topic as well, and that is the validation suites. So the validation suite, software validation is very important in the industry. It has been for many years in the preclinical and clinical space, and it's also starting to be more important in the pharmacometric space as well. So the regulatory agencies do require software validation to show that the software is producing consistent results in different computing environments. Historically, validation efforts might be manual test cases performed by an end user and manual cross-checking of results, maybe with a third-party application, which can take weeks or even months to complete. The WinNonlin and NLME validation suites are integrated into the Phoenix platform and provide software validation in less than 30 minutes, with the kind of the deliverable being a non-editable PDF report containing links to saved reference files, output files, and different files. So the NLME validation suite is integrated with Phoenix. It does require a software license to activate it. It runs standard test cases in the user's environment. And what it does is it runs a series of steps that's designed to test certain features of the software. So it takes a standardized input file, runs it through a standard series of steps, and produces output, and then compares that output from a similar file that was produced at Certara using the same data set and same workflow steps to achieve the result. And then it evaluates the differences between those and compares them and sees whether they're comparable or not. Okay. It also comes with the template documents in Word, such as the software requirement specification, the validation test plan, the traceability matrix that link different test cases with different functional requirements for the software, and so on. And the computational engines verification report shows comparison of results from, for example, NLME with other softwares run with a similar method. Despite all of that output that you're getting, it's very easy to use the product. You simply, with an active validation suite license, select the validation menu and select Start Validation. It runs through the different tests that test different aspects of the software, giving you a checklist as it's running to show you the status report. But typically, this is going to take on the order of minutes to complete everything. And then you get the automatic generation of the validation report, which is shown here. This is a sample snippet from part of the report. So by test case, you get a status, pass, fail, which results were shown. The results worksheet, omega, overall, or theta in these test cases, or in the case of Bootstrap, boot omega, boot theta, boot overall, and so forth. And then there's these blue embedded links that allows you to show the reference file result, the run file result, and the difference result. So, ideally, if a test case passed, that's great. But if you want to examine one in further detail, you can see the exact files that were used for comparison to produce that.
네, 설명 잘 들으셨는지 모르겠습니다. 지금부터 Q&A 시간을 가지려고 하는데요. 질문 있으신 분들은 물음표 표시 눌러주시고 질문을 해주시면 좋을 것 같습니다. 일단 뭐 질문해 주시는 동안 저희가 이제 이 웨비나를 개최하면서 많이 질문하셨던 것들이 좀 있어서 그런 것들 몇 가지만 좀 말씀을 드려보겠습니다. 뭐 아시겠지만 최근에 이제 클라우딩 관련해서 많이들 이제 관심을 가지고 계십니다. 그래서 이 윈놀린 제품 같은 경우에도 클라우딩으로 출시가 되는지에 대해서 많이들 궁금해 하시더라고요. 뭐 역시 이제 많은 분들이 그런 요청들이 있었고, 세타라에서 지난 7월에 윈놀린 그 클라우드 서비스를 출시를 했습니다. 그래서 데이터 인테그리티 측면뿐만 아니라 GLP 그리고 FDA 21 CFR 파트 11 규제의 시스템 밸리데이션 및 메인테이닝 데이터 관점에서 고객 및 시장의 요구사항을 반영한 그런 이제 플랫폼으로 글로벌 시장으로 진출하기 위한 주요 필수 사항들을 한 번에 해결하실 수 있을 것 같습니다. 자, 그리고 뭐 이런 클라우딩 서비스 같은 경우에는 데이터를 또 어디에 저장하는지 많이들 궁금해 하시는 것 같아요. 그래서 그 데이터 같은 경우에는 FDA 21 CFR 파트 11에 맞춰서 그 서타라 인테그랄 클라우드에 저장이 되고 있습니다. 네, 뭐 몇 가지만 더 말씀드리면 그 PK 서브밋하고 관련해서 이제 주로 뭐 SAS를 사용을 하시는데 그것하고 이제 PK 서브밋을 비교했을 때 얼마나 시간이 절약되는지에 대해서 좀 많이 궁금해 하시더라고요. 일단 뭐 결론부터 말씀드리면 상당히 이제 시간이 절약이 된다라고 말씀드릴 수 있을 것 같습니다. 그 NCA 프로세스를 진행하는 동안에 시간을 더 들이지 않고 PK 서브밋을 통해서 SDTM과 ADAM을 생성을 할 수 있게 됩니다. 뭐 그에 반해서 SAS와 같은 소프트웨어 같은 경우에는 뭐 며칠이나 몇 주가 걸리는 경우도 있기 때문에 굉장히 상당한 시간이 절약된다라고 볼 수 있을 것 같습니다. 네. 혹시 더 질문들이 없으실까요? 지금 저희가 이 제공한 웨비나 같은 경우에는 그 녹화본을 저희가 안내를 드릴 예정입니다. 그러니까 뭐 녹화본도 확인하시고 여러 가지 이제 필요하신 부분들 다시 한번 봐주시면 좋을 것 같습니다. 자, 그러면 오늘 뭐 많이 바쁘신 와중에도 많이 참석해 주셔서 굉장히 감사하고요. 오늘 웨비나는 여기까지 하는 것으로 하겠습니다. 뭐 나중에 혹시 궁금하신 부분들 있으시면 저에게 연락을 주시면 저희가 최대한 지원하도록 하겠습니다. 네, 오늘 경청해 주셔서 감사합니다.